All right, thank you everyone for joining our webinar series. We've been having these March webinars kind of to try to get us in the planning mode. So March is a good time for planning, and today we're going to talk about salinity. This might be the year to do some action and try to work on some of those areas. So we are very excited to have here with us today Kent Vlieger. He is a state soil health specialist for South Dakota, USDA NRCS. And Kent is going to start us off. We also have Van Manchime and Dennis Hoyle, two directors with the coalition who have some experience with some saline areas. So we're going to have that discussion after Kent does his presentation. So thank you, Kent, and I will let you start sharing your screen. Kent's information is so valuable. It's a great opportunity to learn a lot behind the scenes. So thanks, Kent.
Okay, can everyone see my screen well? Yes. Am I coming through well? Okay, good. So glad to be here with everyone this afternoon, talking about salinity. It's a topic that's really kind of grown to be something I'm pretty passionate about because I see so much of it. Especially the James River Valley where I live. I'm in the Huron area, and which is kind of right in the heart of the James River Valley in South Dakota, and really throughout the eastern side of the state and somewhat in parts of the western part of the state. I also see salinity starting to be an issue for producers in their production. So today we're going to talk about saline soils, a little bit about maybe salicity too if we have the chance, but we're really going to focus on saline soils today. And so the title of this is called Salt or Fertilizer, and I think the first part of the title is going to be obvious. Saline is really salts, and the fertilizer part will become more clear to you hopefully as we go through this. To start off with, we're going to look at impact, and what does impact mean? Well, it can mean economic impact, it can mean production impact, it can be how you manage an area. And so to start off with, we're going to look at economic impact because I think that's an area that really kind of focuses our attention, and how these areas, although they may be small in percentage of your fields, they really kind of add up as far as hits to your bottom line and putting you in the red instead of in the black at the end of the year. So my predecessor to my position, Jeff Hemingway, did a fact sheet for the James River Valley, and it focused on 3 counties: Beadle County, which is where Huron is, and then Brown and Spink, which would be Aberdeen and Redfield. And there's a really high concentration of these saline soils in those 3 counties. It's really kind of the heart of the issue, and so that's why he chose these 3 counties. But what he was wanting to do is show how much of an economic impact these saline soils were having in just those 3 counties, and just to really maybe to get producers to focus on remediating those areas. And what he did is he looked at the main crop types in the area, which would be corn, beans, and to a lesser extent wheat, and he took the value of straight grain sales. So this is grain sales. It's not necessarily the economic impact as a whole to a producer, but it'd be straight loss of sales in these 3 counties. And so what he came up with is quite a big impact. And if you look at the dollars, you can say, well, prices are higher than that or lower than that right now. But really what I want you to think about is how much does this potentially affect you? Does it affect producers the same way? Does it really matter in the end? It's just a small percentage. Well, if you look at it, it's $26.24 million over those 3 counties just in grain sale loss. And so if think over 3 counties, if you extrapolate that out to a good chunk of eastern South Dakota, it's obviously a lot more dollars that are involved in grain sale loss. But what I wanted to do is I wanted to see really how much does this affect a producer, an individual producer economically? What is that loss to a producer that maybe has a few acres of salinity here and there in each field, and what does that do to their bottom line at the end of the growing season? And so I've got for you here is an example from the James River Valley here in Beadle County, and it's just what I'm going to start out doing is kind of showing just kind of a time lapse of what happens on some of these acres. And so this is a field, obviously along a drainage way there. And you can see by the rows of bales that it had been hayed, and it had been hayed for a number of years. And this is actually 2006, which was the last year it was hayed. And after that, it's been in row crop production. So just pay attention, look at the field, just notice any areas of production loss and what may or may not have happened. So this is 2010, a couple, 3 years after it had been hayed last and in row crop production. 2010 in Beetle County was really quite wet, so there was large areas of prevent plant, which you can see on this field also. Really no obvious saline areas that are showing up quite yet. Nothing obvious just by looking at aerial imagery or even out in the field. But as we go through the years, you're going to see those areas pop up. So now if you look along the drainage way, you'll notice there's areas that are just starting to lighten up on the soil surface. And based on soil type, you would expect that. It was kind of a Durstein soil down there, which is really naturally high in salts close to the surface. But there's also areas in the southwest part of the field and the southeast where you've got some salinity starting to show up. 2014, another couple of years later, and those areas are really well defined now. You can see they're really quite bright white, almost as white as a sheet of paper. And you know, there's really nothing being produced on those acres. You can see that they were planted through and managed like the rest of the field, but there is no crop germination at all. And based off of what we're seeing from aerial imagery, there's very little of any germination, even of foxtail barley or of kochia. Okay, so this is 2016. Those areas are becoming more prominent and larger. And that's the last year of imagery that we're going to look at. So what I've got is I've got 2018's yield map for this producer, and it was corn that year. And so you'll see, just like a typical yield map, it's got those shades of green, and then it goes all the way to red. And some areas of the field where there's nothing produced, it's just no color at all. And so being on this field and working with the producer a little bit, we've got areas that are identified as saline. And we're going to get to those here real shortly. But first, what I want to do is look at the yield map and really what we came out to for yield and the potential economic impact. So you can see 116 acres is the field size, and in 2018 it had an average total yield for corn of 182 bushels, which, you know, is pretty good. I think most of us would be happy with that on an average year. You know, I know eastern parts of the state are going to be pushing those yields a little higher, but for Beetle County, that's a better than average yield. So those are those areas that we identified here that are circled in yellow that had saline problems. And you can see, especially along that temporary stream, the drainage way there, and in the southwest and the southeast, we've got areas that are identified as saline. You will notice there's another strip where the yield was lower, kind of along the western edge heading towards the northeast. That's a sand ridge, and a little lower yields there if we ever get a little drier time throughout the year. It's not a saline issue, it's just another soils issue, being a little prone to drouthiness. So what we're going to talk about is the economics for producers on these areas. And so you're going to have to bear with me a little bit. There's a lot of numbers, and Cindy has promised me this will be posted, so you can go back and listen to the numbers if you want or need. But what I'm going to tell you is that these numbers are pretty conservative. I didn't use any numbers that were for really high cropland values or really high corn and soybean yields or prices. This is just pretty average numbers. And so I'll often get the argument, well, that doesn't match really my operation, and those numbers are way too high, or those numbers are way too low. But just know that I use really conservative numbers for these. And some of these are some of the producer's actual numbers that he was willing to share with me. So on that 116 acres, that 182 bushels per acre average, that comes to 21,239 total bushels that were produced on this field. 8 of the acres on this field were saline that produced 0 yield. And so that's nothing harvested. So these acres were planted through, they were sprayed, they're managed like the rest of the field. They've got land costs, you're paying taxes on them, all those costs that are associated with production for every producer. 8 of those acres produced nothing. So that's 100% loss. The second the tractor tire was turned on those acres, money is lost. If you were to take, or that producer was to take those 8 acres out, the average yield in that field goes to 195.4 bushels per acre. That's a 7.4% increase in average yield, which I think is pretty significant. You know, the ag markets are looking a little better now, but the previous 4, 5, 6 years, they really weren't great. Hopefully this year they're going to pick up. 7.4% yield average on a field is really good. That affects your APH for crop insurance purposes. So that's something that a producer can just look at and say, well, I've got a higher average yield. That's better in and of itself. Another 8 acres that were saline affected produced 50 bushels or less. And you can see that looking at the yield monitor here, there's those really dark red acres, and really some of the bottom yield marks aren't even necessarily shown real well on the graph, but they're there, 50 bushels or less. If he was to take those additional 8 acres out, then his yield increase is 13.7 and his average bushels per acre goes to 207 bushels per acre. I think that's pretty impressive for Beetle County, would be 207 bushels per acre average yield on a field. And that, like I said, that goes back to your APH, lots of things that are associated with it, not just your average yield and your economic cost. So I often get, when I bring this up, I say, well, are you arguing to just take those acres out of production? And I'm certainly not. In fact, my argument is the other way. I'm just stating that even if this producer did nothing with those, just let them go fallow and go wild, they'd be money ahead. And my argument will be later as we're talking more management and saline soil formation on what we should be doing with these acres to keep them in production while we're restoring them. But if he takes those acres out of production, all those 16 acres, he's really only down 400 bushels for the whole field. Because you can remember 8 of those acres produce nothing and the other 8 produce 50 or less. So his total goes to 20,845 bushels produced. So the argument could also be made, well, I'm producing less bushels. How can I be making more money by producing less bushels? And here's how that happens. We all know there's the input costs. Like I mentioned, you've got equipment cost, you've got seed cost, fertilizer cost, spray cost, land cost, which could either be in the form of land payment or through rent. You've got your property taxes you've got to pay on those. So there's all those associated land costs. And on that field, previously when he farmed everything, he had a $17,575 net. So there's profit still being made off of that field in 2018. I think a lot of producers might be happy with that. And I would agree, that's pretty decent profit for this field. But if he were to take those 16 acres out of production and try and restore them to something else, wasn't growing corn or soybeans on them, then his net goes up to $23,455. That's a pretty big deal. That's $5,880 worth of profit. Additionally, it goes to that producer by not cropping acres. I know that's sometimes hard for us to wrap our minds around, but on these acres, they're a loss. Some of them are obvious when you're not producing anything and you don't have a crop to germinate. Others aren't as obvious when you have a crop that looks like it's doing generally well, but the yield is way reduced. So what do we do with these acres? Well, in this case, I'd recommend a producer plant it back to a perennial vegetation. And if you've got livestock, I can make that argument pretty easy because you can use those acres for hay ground or to graze. If you don't have livestock, maybe work on selling those acres, those hay acres to a neighbor. But you can certainly see that you're not going to get anything out of those acres if they're managed as is. So if we take those dollars that we've talked about and we apply those to restoring them, even if you restore with really expensive perennial grass and alfalfa mix, you're really only looking at, I say only, it's because you're still going to make money in the long run. It's $115 an acre for seed cost and to get those acres seeded with a really expensive mix. And that comes to, in this producer's case, $2,240 to restore it for a single restoration year cost. So that's still lower than the $5,880 that he loses by trying to operate those under traditional row crop production. So what I did with this is I took these numbers from this producer who is pretty good producer, pretty much no-till. So this is just also an example that no-till doesn't solve everything. I took these acres and I took these dollars and I extrapolated them out to that 3-county area, the Brown, the Beetle, and the Spink counties. And I looked at how many producers are in those counties. And so according to FSA, there's 2,300 farms and farmers in those 3 counties. And I took these dollars from this producer and I just took a real conservative number of $10,000 lost per section over that tri-county area. And that'd be pretty conservative because this producer is losing just $5,800 on just a quarter section. So if we take that $10,000 loss per section over all the acres in those 3 counties, that's $45 million in direct loss to producers. And over those 2,300 producers, that's just shy of $20,000 of economic loss to each producer averaged out through those 3 counties. And that's with 10% of the acres is what I used that are saline affected in those 3 counties. And even that might be, I believe, is pretty conservative. I believe it's closer to 15% of crop production acres in those 3 counties are salt or saline affected. So there's the economic impact we have. It's pretty extensive in my opinion. And these acres are not going to fix themselves. In fact, they tend to get worse with the same management. We need to basically use or be a little more intensive in our crop rotation to hopefully use more water. And if you can't fix it with crop rotation, then we're looking at perennial production. So I'm going to talk a little bit now on what these saline acres are. And you can see this is a talk on saline and sodicity, but we're going to focus mainly on saline, so that's the bigger issue throughout most of eastern South Dakota. So a definition is basically just what's saline. What are we talking about? How much salt in the soil does it take for me to get a yield loss or for a crop not to germinate? In South Dakota, the types of salts we're looking at are mostly sulfates of calcium and magnesium. There can certainly be other ones, but those are the predominant ones that we tend to see, especially when we pull in soil tests and can identify those salts that we're looking at. This is a good chart to let you determine if you've got saline or sodic soils based off of soil tests. I would encourage you, if you have these areas and you can't identify them readily just by looking or through other experience, I would encourage you to get a soil test and take that, send that into a soil testing lab. Most labs do have saline specific tests. And if they don't have anything listed on their website or when you call them, just ask if they can do a test if you're trying to determine what the salts are and your level of salts. But this will define it for you and if you meet certain thresholds for it to be saline. And so if you look at this top row under saline, anything with an EC that's over 4, so that's that electrical conductivity, over 4 is going to meet that definition of being saline. 4 is just kind of that base level. If you've got an EC of 4, you're probably not going to get real great germination, if any, on your corn and soybeans. You may see germination on some small grains, but you're certainly going to see yield loss. Just to kind of put in perspective for you, an EC of as low as 1.2, 1.5 will see a pretty good reduction in corn yield. So you'll have a crop that will germinate. It may even look healthy like the rest of the field, but you're still going to see yield loss at an EC as low as 1.2 to 1.5. Usually the soil pH in these saline areas is pretty normal. It's usually not too high or too low. The sodium is going to be lower in these saline acres. One of the ways, if you're trying to decide whether it's saline or sodic, other than sending in a soil test, which I would encourage, is that I'll hear producers say, well, it's really soupy and kind of greasy on the top, and when it's wet, and then when it dries out, it really gets hard and doesn't allow water to penetrate. If you're having really those soil structural issues, you could have a sodicity problem also, and a soil test would let you know what those results would be. Okay, here's just some more different ways to read salinity, and won't get into this too much. Really, the best way is through a soil test and looking at your EC. or your acidity values. Okay, this is just talking about what some of these salts are in South Dakota. And like I mentioned, the sulfates of calcium and magnesium are our predominant ones. And so this gets back to the second part of the presentation title, salt or fertilizer. This gets to the fertilizer aspect. Calcium sulfate, which is inherent in most of our soils in South Dakota, really is gypsum. And I think, as most of you know, gypsum is a pretty heavily used soil amendment in other parts of the country. And I'm even starting to hear of some producers interested in it in South Dakota. But it's really it can be used as a soil amendment. Magnesium sulfate is essentially Epsom salt, not necessarily used so much in the plain states or in row crop production as it relates to corn or soybeans, but in other types of production, more vegetable type, potatoes, peppers, tomatoes, that type of thing. It's a fertilizer. So we've got this stuff out there in our soils, and when it's where it's supposed to be and at concentrations that it's supposed to be, it can be beneficial. It's going to be something that a crop would uptake and use for its growth and production. But when it's concentrating really high at the surface, which is what we're starting to see, that's when it becomes problematic. So we've got these saline soils. Why does it negatively affect plants? Why don't plants like these high concentrations of salts? And the long and short of it is, it really creates an environment that's almost like a drought environment for most of our row crops. And you can see on this kind of hand-drawn graphic on the right of your screen that if you'll remember back to your high school physics or chemistry days, and you're talking about that osmotic effect, so basically water movement through a permeable membrane, the water will always move from an area of low concentration to high concentration. So if you look here, you'll see lots of little dots, and that's basically representative of our salts. And you've got an area on the right where there's not as many dots or that salt, so that water wants to kind of even that pressure out. It wants equal amounts of salts, for example, on both sides of that membrane. And that's what causes problems for a lot of our crops, because our roots are really relying on that osmotic potential. So basically, you've got this water that's almost pure that's in the soil, and it's going to move into that plant root, which you look at this line here for that membrane, that's essentially the boundary of the plant root. And the plant root has higher concentrations of, think of it like electrolytes. You know, if you're drinking a Gatorade or Powerade, they always tout that they've got electrolytes in there. Those electrolytes are essentially salts. And that's a way to think of the fluids that are within a plant. They've got a little higher concentration, so it's easier for that water to move from outside the plant inside the plant. When we have saline soils, the reverse is what's happening. We've got higher concentrations of salt, or those electrolytes, you can say, on the outside of the plant than on the inside, and so it can't move that water easily. Now, we've certainly got salt-tolerant plants out there, and they're able to overcome the high salts for different reasons. Some of those salt-tolerant plants, like wheatgrass, for example, have overcome that. They're either drought tolerant, so they can either take in less water and still survive, or they're able to actually bring those salts within their own tissue and still not have big issues, or they're able to exclude those salts somehow. Those are the three ways that a salt-tolerant plant can get by those high saline areas. Okay, this is just a good chart of showing various salt tolerances of some predominant crops, and most of these would be familiar to a lot of us listening. And it shows basically whether they are really sensitive or whether they're really quite tolerant to higher levels of salt. And for the most part, this is pretty accurate. There is one area where I disagree with the chart, and that is under our soybeans. It's got soybeans as moderately tolerant to saline soils or high salt soils. And from my experience in South Dakota, that is not true. I really consider soybeans to be quite sensitive from my experience. And I guess I'd look forward, if you've got other experience where you think that's true, then I'd love to hear from you. But I see soybeans as really quite sensitive. They really don't germinate once those saline soils are getting even to really lower levels. Okay, this is a graphic from a publication that that NDSU puts out, and I'm going to refer to this publication a couple of times. And well, I think I'll ask Cindy if we can find a way to either get that out to our listeners or post that later. But they do really have a good fact sheet on saline and sodic soils, and it explains what's happening, and it really has some good graphics for the visual learners out there on what's happening. So I'm just going to talk real briefly on sodic soils. Sodic soils are really a tougher fix than saline soils, and that's because those saline soils, we can move those salts up and down within the profile more readily than if we have these sodic soils. The sodic soils, what happens is you've got those sodium particles and they bind to clay, and they're essentially, think of them as a large particle, and they weaken the binding of clay aggregates, and they basically disperse them into their individual particles. And so it basically forms just like a brick when it's dry, and when it's wet, it forms really an impenetrable barrier for the water to get through. So this is what happens when you get high sodium. It disperses those soil aggregates and into their really fine, small individual particles. And if you also remember from your soils teaching, if you had some of that, clay is the smallest mineral portion of our soils. It's microscopic, an individual piece of clay. You need a really powerful microscope to see an individual piece. So when it falls apart and is not bound in aggregates, it can really fill in all the cracks, it fills in all the pores, and really binds those areas tight and does not allow exchange of gases, oxygen in the air, or nitrogen through the air also. And it does not allow the water movement either up or down readily. So when we have these sodic soils, they're really quite tough to remediate. And this is just a simple graphic of what happens. Once that soil surface is sealed through sodicity, it becomes problematic because we can't move that water down, and we can't pull those sodium soils back lower into the profile where we want them and where they belong. Okay, so here's that chart again, and keep on going. Saline sodic soils, which we do have some of those showing up in South Dakota, can be also complex because we can get rid of the saline or the salts. They can leach through the soil profile faster than the sodium portion. And really interestingly enough, those salts are actually helping to aggregate the soil, so it keeps those particles bound together. And once we take those high salt levels out, then it just leaves the sodium, and those sodium, as I just explained, can break apart those aggregates, and then we're left with really quite a problem with soil structure and water movement. So I'm just going to show a series of soil tests, and I'm not going to spend much time on this. This is meant more for kind of a live in front of a group, but if you'll look at the first row, just look at that quickly and see if you can decide whether it's saline, sodic, or saline and sodic. And then for the next 3 rows below that. So what I'll tell you is that the first row is saline and sodic because it's got an EC higher than 4, quite a bit higher than 4, and it's got the sodium at a level that's higher than the allowable limits. Same for the next row. We've got an EC of 25, and the sodium absorption ratio is at 29. And then we get down to the third row. The third row is still saline, although it's better than the other ones. It's at an 8.7, and the sodium is now at a level that's not considered sodic. So this would only be a saline soil. And the last one we have is just barely saline. It's 4.5 on the EC chart. So to keep this chart in mind, we're going to come back to it here in a little bit. Okay, so the cause. What is causing these salts? Are they just appearing out of nowhere? Are they falling from the sky with the rain? Or are they something that's always been there? It's just that now something is going on that's causing them to become a problem for our production. So really, this is what happens. The long and short of it is it's a broken water cycle, especially as it relates to our soils. So typically what happens, if we were to go back 200 years on the prairie and it was nothing but 6-foot tall grass, what happens in a typical year? We get the rain that's usually heavier in the spring, and it infiltrates into the soil, and the soil profile is really pretty full. And then throughout the year, those prairie plants are using a lot of that moisture. And a lot of years they would suck that soil profile almost dry. So every time it rained, the water was moving down in the profile. It was entering in and moving down. And what happens lately, especially with our higher precipitation years that we've been having, really for the past 50 years, our precipitation trend has been really quite significantly increased. And I'm going to show a graphic of that here shortly too. What happens with row crop production is we don't use enough water. And I know in South Dakota, that doesn't seem like an allowable thing to say. I know it's drier in some parts of the state right now. And some parts have gotten some moisture, so it's looking more positive. But long and short of it is, a lot of our row crops don't use enough water on an annual basis to keep that water moving in a downward direction in the soil profile, as opposed to moving up. And so what happens when we don't use enough water, and if we have a water table that's within 6 feet, that water moves up through capillary action. So just like if you take that brawny paper towel and dip it into a little water that's spilled on the table, it'll suck that water up. That's capillary action. The same thing happens in the soil. And it can really move quite a bit through the soil, more than you would think. It can move in a lot of our loam soils, silt loam soils, even fine sandy loams. It can move upwards of 8 feet from a water table to the soil surface. So that means if you've got water 8 feet below the ground in some of our soils, and that water table is right there on those sunny days and it's evaporating at the surface, it's bringing that water all the way from that 8-foot level to the top. And when that water rises to the top and it's warm, then that water just evaporates. It goes off into the air, becomes a gas again. But it's also carrying with it those salts. And those salts are moving up with the water through that capillary action. And those salts get to the surface and they've got nowhere to go. They don't evaporate like water does. And so those salts are left at the surface and they just accumulate and accumulate and accumulate if nothing is done to address it. And that's why if you've got these saline acres and nothing's done to address them, they seem to slowly grow over the years. It's because you start to use less and less moisture surrounding them and more salts are able to come up on the edges and they slowly creep out. We've done some experiments where we can find that these salts can really move quite rapidly to the surface. When I mean rapidly, I mean over the course of a matter of weeks. 6 weeks is what we found. If you've got a salt within a couple feet of the soil surface, within 6 weeks, you can go from not being saline on the surface to being really quite saline where you're going to see a yield reduction. So that's how fast it can happen under a worst case scenario. So what do we need to do to address these areas? And this is just a photo of a producer that has had an area that was really a field that was almost 25% of it was saline affected. And what they've done here is they've seeded it back to a perennial vegetation. And this is a salt tolerant alfalfa and a hybrid wheatgrass that's salt tolerant. And this producer had livestock, so we had a use for the hay. So this is what they did. And you can see, well, it doesn't look perfect. In the middle of the field, you can see where it's still not real great growth of the grass, and especially the alfalfa is not coming in the middle there, but there is something growing at least. And so this is what, in my opinion, is the best case scenario for restoring these acres is perennial vegetation. And I'm going to talk, this is another producer. This is in the Yale, South Dakota area. So that would be northeast of Huron, if you're not familiar with where that is. But they have a lot of salinity, just the lay of the land, and their higher water table is conducive to salinity really popping up and being troublesome. And so if you look at the lower left-hand corner here, there's an area circled where there's some saline soils that are right on the edge of a wetland, kind of ring around the wetland or pothole effect that we see so much of. And this producer is a long-term no-tiller, had previously had a crop rotation of corn, soybean, and winter wheat. But a number of years ago, 2007, they took wheat out of the rotation. This is the last year they had wheat in the rotation. And I'd like for you to see what happened over the course of the years after wheat was taken out of the rotation. So this is 5 years after wheat was out of the rotation. And if you look at that same southwest quarter, there's now quite extensive amounts of salinity that have popped up, really quite bad. And this would, I think, would catch any producer's attention. Okay, the next photo is is in here for a very specific reason. The producer came to me in 2012 and said, I've got these really bad salt issues. What do I need to do? Over the course of discussion, determined that the salt levels were high, but weren't so high that they couldn't be brought back by intensifying crop rotation. So we actually added wheat back into the rotation the following year, and some barley in areas that with a little higher salt content. And so that's what he did, and didn't completely fix it over the course of a number of 2 years, but he started to get a handle on it. And you can see the neighbor field had salt issues starting to show up too. And this is what I see so often with these salt areas. They're also usually a little on the wetter side, a little tougher to get into in the spring. And if you'll notice, the producer in the eastern half of this section is choosing to till or to work those areas. And while that may make it look better, it maybe makes those salts visually go away. Those salts are still there. And knowing what we know now, that evaporation is really the cause in a broken water cycle, tilling these actually exacerbates the problem. It may make it look better. It may make you think that you're getting rid of those salts, but it actually exacerbates it because it increases the evaporation rate. Okay, so this is how we restore them. Basically, it's long and short of it is through a lot of our soil health practices. You want to maximize your transpiration. So what that means is you want the water to be coming up through the plant roots and not reaching the surface so much and evaporating. And we want to minimize evaporation by using those plants. So we can do that by decreasing our tillage on these sites. In fact, I would encourage you not to do that because we know it increases evaporation. No bare ground. Bare ground, quite frankly, just allows more evaporation. If we can have that soil surface covered, it insulates that soil surface so that we don't have as much evaporation when the sun is heating it up. And also protecting from erosion. And a mixture of plants and living roots. And so that's how we do this, is we restore it through plants. Plants will 100% fix these acres. Now, how fast that happens is really how severe your issue is. Some sites are going to be able to be remediated within a number of 4 or 5 years, but a lot of sites are going to be a longer term play as far as how long it's going to take to put those maybe back into row crop production. And the harder realization might be a land use change. Maybe row crops are not the best land use for that, the best way to make money off of those acres. Establishment issues is always a problem on these areas. Like I said, they're usually on the wetter side. So it's tough to get them in to seed them in the spring, which is really our best seeding time is the spring. And we've got some of these areas that are so far saline, so far gone, that even our most salt tolerant plants are not going to grow in them. And so those are those sites where it's a really tough management issue. So then we may be looking at putting plugs in. But that's an expensive issue, expensive management. I'm not really aware of anyone that's doing that on a full scale. I'm aware of some research being done with plugs and sprigging, but I don't think that's necessarily an economic issue that we want to look at. But if it's bad enough, maybe it's something that we can consider. Okay, so we want to wait for the question results to come in, Cindy.
Yeah, I was just going to see how many would get their answer in, and we have about half participated. So I thought I would just throw that out since you just asked the same as what I had in my poll. So it worked out pretty good. But if you want to go to the next slide, I will shoot that up here just once. We have about 60% people voted.
Okay, so here's just a graphic tying again back to what's happening with the water cycle and why we want to fix it with plants, because we want that water to be used and we want it to be done through the plant. We want something growing out there so that we can potentially harvest it or use it in some respect, so that we can still count these acres as production and still get some benefit to our pocketbook off of them. Okay, so these are just some species. Most are going to be familiar to a lot of us. Here's some species that I like to use when I'm working with producers, and they're tried and true ones. There are some newer varieties that are out, and there's certainly other ones that we can talk about. But these are ones that are really popular and, in my opinion, pretty economical to use. Tall wheatgrass is one to certainly look at. It's cheap, readily available. It's got a really high tolerance to salts. The only downside of tall wheatgrass is it doesn't necessarily have a lot of forage value for livestock. Once it gets to a certain growth stage, it's really not that palatable. If you're grazing it or harvesting when it's young, it can be. But for the most part, tall wheatgrass is really just something to keep growing and use a lot of water and grow in the salt areas. And it does have really good wildlife value, however. So if you're willing to put these acres just to wildlife use, then I would consider tall wheatgrass. The next one down on the list is New High. It's a hybrid that's been around for quite a while, and it's tried and true, really quite saline tolerant, establishes pretty well, and it's pretty available also. This is one that I would consider if you're looking at using these acres to reduce some type of hay or forage value or through grazing of livestock, because it's significantly better than tall wheatgrass. Green wheatgrass, this is one, there's a specific one's called AC Saltlander that I'm really keen on. It works quite well. The cost on it has come down over the years because there's more seed available, although it's still a little more expensive than some of the other ones on here. It's got really good feed value. It's got really good salt tolerance, and it can also take some standing water out there. We've got some fields that have been standing water for 3 or 4 weeks, and that green wheatgrass will still pull through. So I really like that AC Saltlander variety. And it grows well with alfalfa, which we'll talk about here in a second. Western wheatgrass, or state grass, it's a cool season. Really grows just about anywhere under any conditions. It's got good salt tolerance, though not great, but it is really well suited for grazing. And so if you're a livestock producer and you know you're going to use some of these salt acres for livestock grazing, I would consider wheatgrass in my mixture. Beardless wild rye, not as familiar to most of us, but seed is available. Maybe a little on the expensive side depending on the year. It's got really good tolerance. It's strongly rhizomatous, so that basically means sod forming. So if you've got those areas that are really, if you've got 5 acres of saline soils where it's really crusty white on the surface and nothing grows, if you can get beardless wild rye established around the perimeter, as the salts are drawn down and it becomes less saline in those areas, the beardless wild rye will move in really quite quickly just because of its rhizomatous nature. Creeping foxtail. Now, this is, I'm specifically talking about Garrison creeping foxtail here. A lot of this you'll kind of see throughout the countryside just because it spreads by seed, and when it's got a wet area that it likes, it'll kind of take over. But I like including this in mixtures where it's really a quite wet field, where it has ponding for a good chunk of the spring. And that's just because the foxtail is something that uses water. It likes to be in water and those saturated soils. Even though it doesn't have the greatest salt tolerance, it still uses water, which is what we're looking to do. Okay, alfalfa. This is one we get lots of questions on. And a lot of alfalfa varieties are not known for being salt tolerant, and they're not. And most alfalfa is not really fond of having wet feet. But we all do know that alfalfa uses a lot of water. It's kind of a water-hungry plant. It's very deep-rooted, and so it's got some traits that we like. It uses a lot of water, and it's deep-rooted. There are some varieties out there that are salt tolerant, and some seed companies have their own varieties that are listed as salt tolerant, and they do have some salt tolerance. Most of them not nearly as salt tolerant as our grasses. But we do want to include alfalfa in those mixtures, and it just helps these mixtures be more economic. It helps you recoup your costs. You can hay these acres. It increases the feed value on them. Most of these species are cool season. Grasses, a lot of you will recognize there just aren't as many warm season grasses that are salt tolerant. Switchgrass is one that some varieties do have some tolerance, and it's probably worth putting in some of your mixtures in certain situations. And I'm going to fly through these. This is just another time lapse of a field. And really the point here is that these salts don't show up overnight, so don't expect them to go away overnight. You need to manage them just like any other special management area you might have in your fields. This is that field I showed a picture of with the alfalfa and the grass mixture. And these tests, if you'll look at previously in the presentation, these tests are all from the same field over the course of years. The first test is the very first year before anything was planted. And then the following years are after we put the saline tolerant alfalfa and the AC Saltlander mixture out there. And so over the course of 4 years, we really were able to decrease a lot of our numbers and get it almost to be not quite saline. And we really were able to reduce the acidity out here. And you can see some of our other numbers that were dropping. Our magnesium levels were quite high. And so this to me indicates that it was sulfates of magnesium that were causing us our problems in this field, because those numbers really dropped fast along with our AC values. And here's some pictures. This is a first year of that AC Saltlander wheatgrass and a salt tolerant alfalfa. And this is what happens. You've got a little salt area here, and you can see the alfalfa grows along the edges of it, and a couple even germinated within. And the grasses germinated throughout, although you can see they're kind of sickly yellowish green looking, they're still alive. And this is 4 years later. That area has filled in really quite well. The alfalfa has survived and thickened up a little bit, and the grass is pretty much covering the surface. And so that's how we draw these areas down, the salts down. We're using that moisture every time it rains. We're getting those salts to move back down lower in the profile where they belong. Okay, that's a lot of information. Hope I didn't put anyone to sleep, but I guess if you've got questions, or Cindy, if we're going to open it up to our producer discussion.
Yeah. Well, great. Thank you so much. Everyone. Yeah, that was great information. I think that starting off with those economics, those numbers really are stark, and people are not definitely thinking that they're losing thousands of dollars on a few acres of ground. So we really want them to realize the importance of looking at every acre count, and that is one solution. So we're going to bring the panel on if they want to go ahead and there you go. Thanks, Kent. Perfect. All right. So like I said earlier, I do have Brian Johnson, Dennis Hoyle, and Van Manchime. They all happen to be directors on the Soil Health Coalition and have used the different practices to help some of their ground. So I do want to, yes, Kent, great question. Yes, CRP is an excellent opportunity for management, and that isn't, when I said every acre count, that isn't one, or that isn't all of them, but there are so many. Recently, NRCS added the CIS, and there are a couple of CIS opportunities as well. So we just want people to understand that there are a lot of different options rather than just the continually doing what you have been doing. So I'm going to let Dennis, Van, and Brian kind of add in, and I'm going to bring up some of the different programs that I have found as well. So Dennis, you want to start? You have yourself off mute.
Okay, I'm way ahead of the game. Okay, so my experience is I've lived here all my life, so I see land that I farmed when I was 12 that we haven't farmed for 10 years because we can't. It's either too wet to get through, or it won't grow anything. It's growing cattails and foxtail, and some places nothing. My amateur attempt to fix that is to put feed cattle on there. Okay, the picture that Cindy just put up, we had a question about alfalfa. This particular saline spot is on the edge of an alfalfa field. And 2.5 years ago, I had an aborted alfalfa bale and I didn't know what to do with it. So I put it in the middle of a saline spot where nothing was growing, absolutely nothing. I figured that I'd have the cattle out there that fall. They could eat it or spread it out, do whatever they wanted with it. I didn't get the cattle out that fall. Weather prevented me from grazing it. I didn't get the cattle out the following fall. After the first year, I noticed a few kochia plants growing around the edge of that bale. I thought that was interesting. This is after 2 years, and obviously we've grown, it's 10 times the growth of the first year. So it appears to me, and Kent, you correct me if I'm wrong here, that the stopping the evaporation on that small bale has changed it so that something can grow next to it. And I just think that's amazing. I have another area where I have some saline where I feed cows when I can, and I'll either unroll a bale if it's a big area, or I'll just plop a bale down like a bale graze situation. And I know I have gotten from growing nothing to growing weeds now. I consider that progress. That's that transpiration that Kent was talking about. So that's kind of, I try to get it covered if I can. And I thought that bale was extremely interesting. That's
right.
The anecdotal evidence as I know of.
Right. So in your situation, that wasn't an area that probably would have qualified for CRP because it wasn't crop ground.
Well, it has, yeah, actually that was a saline area when it was native prairie.
Yeah, that's what, yeah. So there are instances where, you know, some of the programs you do have to look at trying to find the best fit for those options too. So Brian, I know you utilized CRP quite a bit and utilize that in a manner for your operation, healing some ground. And then now, since it came for renewal, you renewed some, but you also took some out, right?
Yes, we enrolled a bunch of our saline acres probably 11 years ago now in CRP. And so the wheatgrass mixes that were a part of that really did the job. You kind of have to not look at them the first 2 years because it just takes a while for that grass to get growing. But now you can't really see any saline issues in there. It's definitely done its job. And we re-enrolled some of it, but the acres that we chose to not re-enroll, we are actually leaving as grass, and we're going to manage them on our own, whether we graze it with the cattle or hay it once every few years. So just kind of whatever works for your operation, what your needs are.
Yep. Yeah, I know Brian and I were at a producer's place visiting with them, and a question came up about some of the different. All right. Do you see a table?
Yes.
Okay. So I just wanted to quick show you this, and Kent touched on it really well, but this was from Stan Bolt's one time, and tall wheatgrass, like Kent said, really does provide an opportunity for something to get growing. So if you're not going to utilize that ground, the one thing I want to point out is that Stan had showed me is the feed value of that tall wheatgrass. When it's higher than 8 or lower than 4, that ratio, it's really, the cattle will lose weight. You know, it just doesn't have the feed value within that, those plants. So that tall wheatgrass is right in there, and obviously the creeping foxtail is as well. So, so if those are part of your goals, you know, that may play a part into what you plant. So I think that is always, you know, with Brian, utilizing it after the CRP was done, after he got it established, the area was healed, the tall wheatgrass just wouldn't have been something that he probably would have chosen to have a high percentage in.
Yeah, it's
Van?
about having a blend of species
Right.
in there.
Yeah,
Exactly.
have that good mix. We have a question to the panel. When bale grazing saline areas, should this primarily be done during the dormant season while the ground is frozen, or does the effects of increasing the soil armor offset the risk of the compaction in the areas? Have you done any of that, you three?
I always bale graze when it's dormant.
Yeah.
If I'm anywhere on crop ground, it's got to be frozen.
Yeah, the ground just, I mean, it'll get the benefit from the cattle, even though it's frozen, you know, in the future years. So you're just not going to risk the opportunity for that compaction to happen. So, great. Van, would you like to add any on some of your experiences with saline areas?
Yeah, I have two different situations. We have a piece of ground quarter that has been no-till since 2010, and it's been we have 6 little fields on it. It's roughly 25 acres apiece, and we've been doing a 4-crop rotation. And in 2015, I started noticing some lower spots that I thought were going to be issues, but we weren't that wet, so we just farmed it normally. But in 15, 16, and 17, we were putting cover crops on them, and then I think in 17, I added barley and sugar beets and rape and rye to try to get those saline areas going. But every fall we'd get a lot of rain and it flooded them out, and so we just weren't getting anywhere. And in 2018, we had 16 acres of prevent plant on that quarter, and I've never had prevent plant before on our farm. We've never had it. And then in 2019, in that quarter, we had 54 acres of prevent plant, and I was sick to my stomach. I couldn't believe it. I just couldn't get out there, and everything was just so wet, and the water was not going in the ground. So I knew I had to do something.
Mm-hmm.
And so I decided to plant the whole quarter to perennials, and we planted it last spring in 2000, and we did a 9-way mix. We added barley to it just to help it go through the drill a little bit better. But we did the 12-week grass. We did the AC Saltlander.
Yeah.
We did alfalfa, and we planned to bale graze on that ground to keep the nutrients and the carbon there.
Right.
But we may not bale to graze the saline areas. But if we can get water to go in the other areas, then the water won't run down into those spots as bad.
Right. Just evident when Kent was showing those pictures, that's kind of the similar. If you're doing things to increase the soil to infiltrate, the other areas will also benefit from that too. So you touched on a little bit, time of year for planting, so if you have a salinity area and you want to try to get something planted, what do you think the best time of the year is for planting?
Whenever you can get it in. So
Yeah.
Interesting on this quarter, last spring, we had some wet spots. So we only got 130 acres of it planted. And then last fall, after we got done with our corn harvest in late November, I was able to plant all the low areas and get it all planted over winter. And I think it's going to be okay. We haven't had too much moisture to flood it out, I don't think. So hopefully it'll go this spring. We did last spring, I think we planted it in the end of April, and we did get a really good stand. We were really surprised how good a stand what we got last spring. So.
Yep. In my experience have been that dormant, Dennis had mentioned dormant seeding or dormant utilization of those areas, but dormant seedings do well in those salinity areas as well, just because of the time, and it allows the seed to be able to germinate the next spring, hopefully. So we may have some opportunity this year with the not having as much maybe moisture in some of those areas. It might be the year for you to try to do it. So we're hoping to provide you guys some options for the people that are listening, options to do that. Some of the different programs we touched on. So I don't know if Kent wants to touch on them. There's a new program called CIS I'm going to try to bring up, but there's 2 for sure in the state that have opportunities for people in just the areas Kent had touched on. Brian falls within those areas. Dennis would be probably just outside of them. I'm not sure if Van would be outside too, but CRP is always an option. I think Kristen is even on for every acre count, so that's a great option too. But I'm going to share. Kent, do you have anything to add on any of the programs?
No, I think you got them all for the most part, Cindy. There's a lot of options out there. And you know, if for some reason you don't get into a program or just don't qualify or you don't want to follow, you know, some of the guidelines or rules within the program, I think the evidence is out there that you don't need a program to make it economical. You can
Exactly.
you can probably make it work on your own, but certainly there's a lot of programs out there that can take some of that first couple of years cost off of restoration.
Right. Yep. Yeah. I do think, you know, the programs are nice to help pay for the seed costs, and there's usually someone that would definitely want to help in those areas, but the economics are pretty evident that you're going to be ahead if you're not planting those areas. So Dennis always, as long as something is growing, it's better than nothing is growing. You're not going to hurt that area, right, Dennis?
That's my opinion. I'd rather see, I don't want to see Palmer amaranth out there, but I'd be happy with kochia, foxtail, because we're getting closer to a wheatgrass or an alfalfa or something. Like it didn't happen overnight. I've been farming here all my life, and that's a long time now. And it changed slowly, and it's not going to get corrected quickly. Kent, I have a question for Kent. How do we take advantage of a drier year? I mean, if this does turn out to be a drier year, is there something that we can do to ramp up our benefit? I assume we're gonna have a lower water table.
Yeah, so a couple of things, and Cindy certainly touched on it, is if you have a drier spring, this might be the year to get those areas seeded down. You know, some of us have gotten some moisture, but I still don't think we're going to be super wet unless we get hit with something later. But yeah, it'd be an opportunity to get something seeded that you normally wouldn't have gotten seeded. You know, and if you do are able to get anything established, whether it's perennial cover or a cover crop or some type of crop out there, actually drier years are years you can see a lot of reduction in salt, because any rain we do get, and if you're using that moisture low in the profile, it moves rapidly. So we've found that with some soil tests too, that sites we test regularly throughout the year, is when we go through those drier parts of the year, anytime we do get a rainfall, those salts move really quickly. So yeah, there's opportunity with anything, and if you have a drier year, some of these sites, it might be opportunistic for them to move salts down.
Okay, thank you.
Yeah, one thing I want to share or ask the panel is, so if you're planting, do you throw on more and more and more seed? Is that economically good for you to try to get something started? Or would it be better just to go with the normal seeding rate and not put on, you know, the extra and pay for the extra in hopes that it would get something started? Anybody have any experience with trying to boost your seeding rates, or did you stick with a normal seeding rate?
Are you talking planting into perennials?
Yep. Or yeah.
I just did a normal seed rate as far as I can tell.
Yeah. Yeah. Those are the kind of the experience I found, or when I talked with other people, is it doesn't pay out for you. You know, some people think, well, I'm going to throw on a lot more seed, I'm going to get something to go. But the normal seeding rate was just as beneficial. You know, you didn't get your pound. I don't know, Brian, did you have a different experience?
We just used the recommended
Right.
rate, and after 3 to 5 years, it was completely filled in. So I wouldn't go, in our experience, going above the recommended rate wouldn't have paid off.
Yeah. Okay.
The conservation district in my county has a test plot, saline test plot. And we planted a bunch of high saline tolerant grasses and plants out there. And a lot of them germinated, but they didn't last very long. And, but here and there you see a wheatgrass plant. And there's some places it's just so hot that nothing's going to grow there.
Right.
But on out there, there are a few plants here and there. I assume they're helping, and I hope they go to seed, because those obviously are a little tougher, more tolerant than the others were.
Yeah. Yeah. So as you can tell, I'm putting a few over, trying to get down the list, and you can take yourself off mute and definitely ask anyone on the panel a question directly, or Kent. That we have quite a few, are thankful quite a few of different NRCS professionals are on as well, and they can add in too to the conversation. So I think salinity is such a opportunity for us to talk together to find out the best avenue to get some of the ground to have something growing on it. It's increasing in some areas, and we really want to provide any help we can to producers and give them a kind of a guide, because it's not any fun to see nothing growing out on your field. So we want to help them to make some good decisions, have some good options, and see what can work on their ground. So does anybody want to take themselves off mute and ask a question, or does anyone have any additional questions for the panel or Kent? Okay. So Dennis had mentioned he would, let anything grow, just so something was growing and utilizing some of that water. So weeds are something that would be possibly growing. But what does Kevin or anyone has any experience on? What do you do if you have like a lot of foxtail barley in there? What would you do? Would you just let it go, or how would you heal it to an opportunity to utilize some of that ground for either for cattle or other avenues?
I think the foxtail barley shows a symptom. And so I personally would address it with, putting in some different perennials that would benefit maybe even a little bit better than the foxtail barley. Right. But foxtail barley is better than nothing. I do agree.
Yeah. It's better
and I agree with Dan there. It's an indicator. It can be an indicator that it's getting worse, or an indicator that it's getting better, depending on which way you're going.
Yeah, good point. Okay. Yeah. So
maybe, can you guys hear me? This
yep.
is Jim.
Okay. Go ahead, Jim.
Yeah. Maybe this isn't a part of the discussion. About 10 or 15 years ago, a lot of salespeople came in pushing calcium in fairly high amounts to be applied to land. And I don't know if this is the right place to talk about that, but that's got to be a contributor to some of our problems out there. Am I correct? Or doesn't it have that much impact? Kent, maybe this is more up your alley.
Yeah, so I don't know how much was actually applied out there. I don't know if it really contributed to a lot of the issues we're seeing. I know it didn't probably contribute so much in the James River Valley, but if they were recommending calcium, it might have been for some sodium problem areas. I really think a lot of our issues is just, like I said, it's a water use issue, and we've got those salts moving up that were deeper in the profile. They're coming up to the surface, so I don't know that we could have applied enough to really make it a big problem.
Okay.
All right, I'm going to share Kent. I will send this out. This is a handout that Kent had wanted everyone to know. Have some valuable information, and I also have some other information from NRCS as well. But it does give, like Kent said, a lot of great tables, information about what to do, when to do, and the reasons for salinity. So everyone will receive this handout. And I will email it out to all the people who are registered with that, but it is a useful tool. So when you do get it, set it aside. Everyone's real busy. So I do want people just to be aware when I do email it out, you will have some attachments on there. Another opportunity for you to have some resources, whether you're an NRCS person or someone who is still trying to fix some salinity areas. to know there are some different resources to reach out to either Extension, NRCS, conservation districts, the coalition, but we'd be happy to help or continue that discussion. Dennis, any final thoughts for anyone? It's about 2:15 already.
No, I guess not really. I think we've covered everything and probably more than I know. But my experience is you can benefit by covering it.
That covered.
An advantage of having livestock. It's easier to do when you have livestock.
Brian, any additional comments?
No, not really. Just don't be afraid to get something grown out there. It doesn't matter what time of the year, but anything's better than nothing.
Yeah. Cut your losses, right? Make sure you're getting something off of those acres. Yeah. Van.
Yeah, just to echo what Brian says, get something green growing out there, a living plant, as long as you can, and start using the moisture, and quit throwing inputs on stuff that's just not going to grow. It's just foolish. It really is.
Yeah, we want, I know it's a little more challenging, that people say, when you're driving those tractors, but it really is going to pay off in the long run for you as you start to see something growing. It might not be your row crop, but it will be something that'll benefit you, and your row crops are going to even do better too. So they're not
even
going
if it benefits wildlife, even if you don't take a thing out of it, if you just benefit some wildlife, make a spot for something.
Yeah, and I see
that isn't the worst thing in the world either.
Yeah, I see Kristen is still on. Kristen, I don't know if you want to add anything in on every acre counts, but that is an opportunity. You can find that on SDSU's website. But if Kristen wants to unmute, you can certainly add something in about every acre counts.
Yeah, thanks, Cindy.
Yeah.
So yeah, if you can go online and find the information on the SDSU website for every acre counts, or my contact information is also on the Pheasants Forever conservation page. I've been working with quite a few growers around the state, just kind of exactly what you guys talked about today with these marginal lands and the salt issues. So it's Ken did a great job of pointing that out with the profitability aspect of it. We see that a lot just by not farming those acres. There's huge shifts and reduced expenses, and your overall profit goes up. So, but yeah, I'd love to work with any of you if you have questions. All I really need is just your precision data that you have from your combines, and then we can just go from there.
Yep. Thanks, Kristen. Yeah, Kent,
One last thing I would say is that Kent did a great job. That was a really good presentation. Thank you.
Yeah. Kent, any final comments?
Not really. If you've got questions or you don't know where to start, we've got field offices in every county. So go in there, and hopefully the local field office employees, either conservation district or NRCS, can get you started down the right path.
Right. Yeah. Great advice. And if I know it's harder to get into some of the offices, but they do have their contact information on the doors. But, you can reach out to the coalition. I will definitely get you in touch with. I have cell phone numbers and different contact information for every office. So don't be afraid to reach out to the coalition. We can help kind of connect you with the right people. There are area resource people as well as your local offices too. So they can be an excellent opportunity for you to connect with them. But we do want to try to provide as much information for you to be able to help that ground and help your bottom line too. So one of our visions, right, Dennis, is to make sure you're sustainable for the future and keep that land as healthy as possible. So thank you everyone for joining, and don't forget to sign up for next week's. We'll be having another talk with some panels. Kent will be back. And then we'll talk a little more about the 5 principles and the whole system. So thank you again for tuning in, and this webinar will be on our website probably in the next day or 2. So thank you very much, and have a great day, everybody.
Have fun.